of webinar. We are very excited you to be here. And without any further ado, I invite Mr. Vikram Murthy, founding member, Foundation for ISHRAE, to commence our webinar. Vikram sir, your mic is...
Yes. So my mic is on now. Neetu,
Yeah.
is my mic on?
Yes, it is.
Okay, I'm sorry. Thank you very much. My name is Vikram Murthy. I'm a member of the Foundation for ISHRAE and a presidential member of ISHRAE. So, as Neetu said, welcome all of you who've come to attend this webinar. I'm happy to let you know that the Ministry of Environment recently released a book on the World Environment Day, and the title of the book is Passive Cooling Strategies for Sustainable Buildings. So this book was authored by IIT Kharagpur, a team led by Prashant Anand, together with the Foundation for ISHRAE, which is ISHRAE, a team led by me and other members whose names we will tell you in the end. So passive cooling strategies is a wonderful thing because it allows us to do cooling of buildings without using any mechanical means of cooling, except when we do ventilation. So even in the times when there's excess heat and we have to do cooling, the cooling load will reduce substantially if we apply passive cooling methods. So now I will request Dr. Lama from the Ministry of Environment to make comments on this program and her thoughts about environment and sustainable cooling. Thank you.
Thank you, Mr. Murthy. And first of all, I would like to pass on the director's message. He was called into a meeting in the last moment. So I have just joined as a senior technical officer at the ozone cell. So I am here to pass on his address to all the panelists and the participants of this awareness workshop. So I just want to give a gist of what the ozone cell is working on and how it can lead to other policy development in ODS reduction, regulation, and so on. So this report on the passive cooling strategies for sustainable building conducted by IIT Kharagpur and ISHRAE, which was released on the 30th Ozone Day, celebrated on September 13th this year, in the presence of Honorable Secretary Madam Leena Nandan, of MUOF-CC. This report is the result of a very critical enabling activity of the building sector's intervention in the ODS policy development under the HCFC Phase-Out Management Plan Stage 2. As we are all aware, India has long been committed to the global efforts of protecting ozone layer in India's ozone in March 1991, followed by the ratification of the Montreal Protocol in June 1992. Over the years, we have continued to demonstrate our commitment by ratifying all the subsequent amendments to Montreal Protocol, including the most recent Kigali Amendment in September 2021. The Kigali Amendment, an important update to the Montreal Protocol, targets the reduction of hydrofluorocarbons, a potent greenhouse gas, and represents a crucial step towards mitigating climate change by promoting environmentally friendly alternatives to HFC. India remains steadfast on its commitment to phasing out the production and consumption of ozone depletion substances, such as HCFCs, through an accelerated HCFC phase-out management program, which is now at its third stage. Our progress in this area has been made possible through a series of dedicated efforts supported by global frameworks and national initiatives. India has the largest unmet cooling demand in the world, and the major portion of the cooling demand is catered to refrigerant-based cooling globally across sectors such as building, cold chain, refrigeration, and transport. Recognizing these challenges and opportunities, the Ministry of Environment, Forest and Climate Change launched the Indian Cooling Action Plan in 2019 that provides a long-term vision for addressing the nation's growing cooling needs while promoting sustainability. The ICAP aims to reduce cooling demand by 20 to 25% and refrigerant demands by 25 to 35% by the year 2037. Cooling in space, space cooling in building is a key focus area under the Indian Cooling Action Plan, aimed at promoting sustainable cooling technologies for both new constructions and retrofitting existing building. The goal is to advance environmentally friendly cooling solutions that not only enhance energy efficiency but also reduce the impact on ozone layer. The future of cooling space in building would greatly benefit from two-pronged approaches. First, by reducing the need for active cooling through implementation of energy efficiency strategies, and secondly, by meeting the remaining cooling demand with advanced and efficient technologies. In this line, with this approach, one of ICAP's key recommendations is to promote the wider adoption of climate responsive buildings. By leveraging passive cooling techniques, we can maintain indoor temperature within acceptable thermal comfort levels, significantly reducing the cooling load and advancing sustainability. Today, as we discuss the future of sustainable cooling, this report on passive cooling strategies for sustainable building serves as a timely and essential resource. It highlights strategies to reduce reliance on refrigerant based cooling and focuses on innovative passive solutions that align with ICAP goals. We at Ozone Cell congratulate the team on developing this insightful report and look forward to a fruitful consultation with the stakeholders to better understand the benefits and challenges of adopting the mentioned strategy for promoting sustainable cooling. Thank you.
Thank you very much, Dr. Lama. It was very nice of you to present the Ministry of Environment's update on what has happened since the release of the India Cooling Action Plan. A lot has happened, and so now we will learn more about this particular book, which was released by the Ministry of Environment, Passive Cooling Strategies for Sustainable Buildings. To do this introduction and give you an overview of the book, I welcome Professor Prashant Anand. Dr. Prashant Anand is Assistant Professor in the Department of Architecture and Regional Planning at IIT Kharagpur. He is the principal investigator of the published book, Passive Cooling Strategies for Sustainable Buildings. He has a PhD from NUS at Singapore and an MTech from IIT Madras. He has expertise in building science, energy efficiency, and digital twin technology. Dr. Prashant Anand research focuses on the intersection of energy, air quality, and urban sciences. His involvement in global committees and editorial boards reflects his commitment to advancing sustainable urban development. Professor Prashant Anand, kindly present your overview of the book.
Thank you so much, Vikram sir, for the kind introduction. I'm sharing my screen.
Okay. You can put on your camera as well.
Yeah, I'm putting my camera on.
Right.
Yeah. So, yeah. Is my slides visible?
Yes.
Okay. Yeah, thank you so much. So, good afternoon, everyone. As Vikram sir introduced me already. So, on behalf of Department of Architecture and Regional Planning, I'm going to present this book, which has been published by Ministry of Forest, Environment, Climate Change, Government of India. And we are deeply grateful to Ozone Cell for giving us opportunity to develop this book with help of ISHRAE. So the content of presentation, first I will give introduction about this book, then I will discuss about the various contents of chapter, then reported benefit, and finally the conclusion that who are the intended readers for this. So if you want to download this book, you can quickly scan here and download this. And at the end of presentation also, I will share this QR code so you can scan and directly go to the link which is available at MOFCC website. So considering time constraint, I'm going ahead with presentation. So this book having a total of 3 chapters and having 66 number of pages, and each chapter having a summary of recommendation. Okay, so this chapter is designed in such a manner that it can be considered as a reference material for general public and building industry professional for towards means sustainable technologies, and it should not be considered as a technical reference because it's more like illustrative information of the various passive cooling techniques and how to achieve sustainability in a building. So the first chapter is about passive cooling techniques, and the second chapter is about building retrofitting strategies, and the third chapter, which is about the selection of building material. So whatever the learning gained from the chapter 1 and chapter 2, with help of that, appropriate building material, how to select that has been discussed in this chapter number 3. So the first chapter, having various subsections, it discusses about how a passive cooling methods can help in minimizing heat gain and heat loss through a building. It discusses about various passive cooling systems like heat protection, heat modulation, and heat dissipation techniques, and why these techniques are important, and how these techniques can be used in the various climatic zones of India. So the next section, why passive cooling is important for India. Here we have discussed about how these three techniques can be applied there and how it can change there. Okay. And finally, at the end of this chapter, we discuss about the reported benefit, means how much amount of energy saving is possible and how the thermal comfort can be enhanced. That also is through various literature. So whatever findings we have reported is through various literature published by various scientists around the world. Okay. So this is how the book is looks like. It is a very illustrative book. Here we discuss about like conduction, convection, radiation, and various cooling techniques. And then this is how we have illustrated like in various climatic zones of India, like what kind of techniques within this subcategory of various heat modulation and dissipation can be categorized. Then finally, the reported benefits are presented like this, like if suppose if you will have a proper orientation and you have a proper shading, and if you are using a proper greenery around the space, and if there is a presence of water body, then how much will be the enhancement in the thermal comfort and how much will be the possibility of energy saving, that through various literature. Now come to the second chapter. Here we discusses about retrofitting strategies for a building. So in past, various effort have been given for design of sustainable building or passive cooling techniques, but less importance earlier was given for retrofitting of existing building. However, the retrofitting of existing building is also very important because it can help in enhancing the energy uses and energy means consumption of existing building. It can help in enhancing the thermal comfort. Also, it can help in mitigating the urban heat related challenges. So this chapter explores the advanced installation techniques and the integration of new and renewable energy sources, and it presents some of the successful retrofitting efforts and reported benefits. So the chapters are like, first it discusses about shading, then it discusses about insulation, then it discusses about cool coating, then green roofs, and then it discusses about integration of renewable sources, mainly the solar panel. Then finally, after enveloping the facade level, it discusses about the system level control, like how occupancy-based control can enhance the well-being of occupant inside a space. And then finally, it discusses if we will go ahead from a building level to city level retrofitting, then what are the possibilities and why this is important. So this is how chapter is starting. It discusses like in various steps, like what are the cost savings and what are the cost implication of having retrofit. Then it discusses about the various method of shadings, like the conventional one, what we are doing in the building, like chhaja and various kind of market available shadings. Then it discusses about insulation, like how to select an appropriate material with appropriate U value for a wall and for a window. Then it discusses about importance of glass and how important is SSGC, and how to minimize solar radiation to come inside a building through glass, and at the same time how to enhance the visible daylight to enhance the daylight inside a building. Then it discusses about cool coating, more advanced techniques like how a cool coating can help to reflect back solar radiation and minimize the heat gain by a surface. And then it discusses about green roofs and how to integrate green roof into a building. Then finally, in terms of integration of renewable energy sources, it discusses about integration of solar panel. And some of the key findings, which is very relevant, has been reported, like if you will use a solar PV in low-rise residential building, then it is possible to achieve net zero energy target, and it can enhance sustainability. And if you will use green roof and reflective shading, it can help in lower peak urban temperature. However, we have to be very, very careful when we are thinking about covering entire city with rooftop photovoltaic solar panel, because solar panel having low albedo, it can absorb heat and it can cause daytime warming and nighttime cooling. So our eminent speaker, when Prof. Matt Santa Maurice will come, he will discuss this thing in detail, like what are the challenges a city can face with varying climatic conditions. Then further, after discussion of envelope, it discusses about occupancy-based control, like how ventilation is important, what happened after COVID, and means because most of the time when we are designing a building, an airtight building, the same air is circulated again and again because we have to minimize energy. When outer air is coming, energy is required to cool down that. So there is a compromise between air quality and energy saving. So this we discuss about how occupancy-based control can create a synergy between energy saving as well as the health and well-being of occupant. Then finally, through schematic, we discusses about how urban level retrofitting can happen and why it is required. Those things we have discussed in a schematic manner. And then finally, like chapter 1, we discusses about the reported benefit, like with each techniques and technology, if you will use, then what are the reported benefits in various literature. Now, in a summary of chapter 1 and 2, the chapter 3 discusses about if you will adopt those techniques, then how will you choose the appropriate material to enhance energy efficiency and to design an appropriate building envelope. So it having a discussion about selection of wall materials, selection of roof construction, selection of insulation materials, and also selection of reflective paints. And then finally, choosing material of window and openings, and how these materials can be used in construction practice through some schematic and pictures and illustrations. We have discussed that. And this is how the things have been reported for wall construction and insulation and coating of the roof. And then like chapter 1 and 2, here also the summary. In summary, we have reported like what are the intended benefits. Suppose if you have wall having this U value, then how much will be the reduction in heat gain, all those things that has been discussed. Okay. So in conclusion, this can be considered as a practical insight book for the construction practitioner, policymakers, and architects. So to enhance sustainable cooling solution in India, and should not be considered as a very technical material. If you have to design a building for your site-specific requirement will be there. So you must refer this book as a general guide to understand what is possible, but you at the same time, you should always refer to an expert to have a customized design specific to your site. So we can acknowledge the effort of all team members, like I work with Prof. Shankar Bhattacharya here, who helped a lot in the development of this guidebook at IIT Kharagpur. Nilabra, our team member, who is the key person who developed all the graphics and the content of this book. And we acknowledge the continuous help of Vikram sir and all the ISHRAE team members like Subramaniam sir, Chandrasekhar sir, and Anand Kumar sir for their valuable contributions. So again, I'm sharing the scan for this QR scan so that you can download the book. We will take your comment and responses around 4:50 soon after our eminent speaker Matt Santamari's presentation. So in the meantime, you can download and scroll through the book if you want. And now I'm introducing Prof. Matt because he is about to speak about the cities and climate, which is very relevant. Okay. So I'm stopping my presentation here. Okay. So let me introduce Prof. Matt Santamari. It is a privilege for me to introduce my past supervisor, and he is our esteemed guest speaker. He is currently serving as a Cynthia Professor and Anita Lawrence Professor of High Performance Architecture at the University of New South Wales. He has more than 30 years of experience in sustainable architecture and urban planning. He is the world's most cited scientist in all domains within top 1% and the top researcher and leading the domain of cities and climate. His innovative research on thermochromic and ultra-reflective material has significantly advanced urban heat mitigation effort worldwide, not only in Australia. A former professor at the University of Athens and visiting professor at several esteemed institutions, including NU Singapore, Tokyo Polytechnic University, Prof. Santamari has also served as president of the National Center for Renewable Energy and Energy Saving in Greece, recently honored with the 2024 PLEA Lifetime Award. He is recognized for his contribution to sustainability in urban environment. Today, we are excited to hear his thought on developing cooler and more sustainable cities. Welcome, Prof. Matt Santamari, and you can continue with your presentation.
Thank you so much, Prasad, for the introduction, and it's a pleasure really to, let's say, address your seminar, and congratulations for the development of the very interesting book on passive cooling. We will discuss about, the problem of, let's say, overheating of our cities. can you see my slides? Can you see my slides, please?
Yes, Prof. You can continue with your
Okay,
presentation.
thank you so much. Thank you so much. The problem of overheating of our cities is a very serious, let's say, problem. Actually, there are more than 13 overheated cities in the world, 13,000 overheated cities in the world. And there are more than 1.7 billion people which lives under very severe overheating. Compared to, let's say, 1980, the number of overheating hours has increased, let's say, by a factor of 3 in our time. And very recently, it was really published that during the last, let's say, 10 years, the increase of the, let's say, man days in India and in China above, during, let's say, the period of heat waves or the man hours or man days, let's say, under heat waves, increases per year close to 509 million days. So it is really a tremendous increase of, let's say, exposure to heat waves. Do we have enough evidence about, let's say, the impact of higher temperatures in our life? Of course. We know very well that really overheating increases the cooling energy consumption in cities, decreases the efficiency of power plants, rises the peak electricity demand, but at the same time there are very important environmental impacts. For example, it increases the emission of pollutants of the power plants, increases the concentration of ozone, and also there is an important impact on health because it increases the heat-related mortality and morbidity and creates important, let's say, mental health problems. But it's not just that. It really lowers the productivity of population, increases the risk of accident, and affects the survivability of vulnerable population. Do we have really quantitative data about the specific impacts? Yes. We know, for example, that in average, urban overheating, it increases the energy consumption close to 240 kilowatt hours per person and, let's say, all around the world. Of course, this number may change as a function, of the specific conditions in the different cities. But at the same time, we know that because of the very high temperatures, overheating is obliging utilities to build additional power plants, and this, of course, increases the cost of the electricity, and the average, let's say, increase of the penalty is close to 21 watts per degree of temperature increase and per person. But at the same time, we know very well that higher temperatures decreases the efficiency of power plants, and especially the efficiency of thermal power plants, of nuclear power plants by about, let's say, 0.6% per degree. So consider, for example, a day with a heat wave where the temperature increase by maybe 10 degrees. In this case, you may have a decrease of the power plant efficiency by, let's say, 6%, which is really very important. On the other hand, because of the extreme, let's say, demand on electricity during the heat waves, we face a very serious problem of blackouts, of grid failure, let's say, in the world. It is well known that, let's say, during the last years in, let's say, United States, where we have very specific, let's say, details and statistical data, the failure of the grid, the blackouts, has increased by about, let's say, 150% compared to the last years. It is very characteristic, for example, what has happened in the United States in June of 2021. Because of the very important, let's say, grid failure, we had 600 additional deaths, 3,500 emergency hospital visits, and of course, hundreds of thousands of people without electricity. A part of the energy consumption and a part, of the energy problem, overheating is creating important environmental, let's say, problems. Because of, let's say, the high temperature and because of the solar radiation, we have really some photochemical reactions which increase the concentration of the so-called ground level ozone, which is a toxic, let's say, gas that has a very important impact on human health. And there is a very important increase of, let's say, the ozone concentration during the last, let's say, 10 years. All around the world, the concentration of ozone has increased by about 15%, and the number of cities which face a problem of higher concentration of ozone is close to 96% of the cities all around the world. But it's not just the creation, or the generation of additional ozone in our cities. Because of the extended use of power plants, we have additional, let's say, emission of pollutants and release of pollutants by the power plants. We know now that by degree of temperature increase, we have about 3.5% more, let's say, emissions of SO2, CO2, and NOx by the power plants. So imagine a day with 10 degrees of overheating, we may have 35% more, let's say, releases of, let's say, pollutants in our atmosphere. However, one of the major problems we are facing with overheating has to do with, let's say, low-income population. We know very well that low-income population lives in parts of the city where really overheating is much more stronger, and at the same time they don't live in proper houses. This really affects the socioeconomic and the biophysical vulnerability of the low-income population, and oblige this population to live really under very high temperatures. At the same time, because of, let's say, poverty, they are not really allowed to use the proper air conditioning in order to cover their needs. For example, in a very developed country in the European Union, Portugal, only the 2% of the cooling needs of the low-income population is really covered. And we have, let's say, thousands of measurements all around the world that shows that during heat waves, low-income population lives under, let's say, indoor temperatures close to 40 degrees for 3, 4, or 5 days, and perhaps higher. And the worst is that because they are closed windows, doors, etc., indoor concentration of pollutants may be 3 to 4 times higher. So low-income population, because of the overheating, lives under non-really acceptable thermal conditions and also under very high, let's say, indoor pollution. And this brings us to the major issue of overheating, health. We know that the human thermoregulation system cannot really offset the impact of extreme heat. And once temperature is much higher than the threshold, we may have important problems. We may have additional heat-related mortality and morbidity. And this affects very much vulnerable population, or those that they, let's say, suffer from respiratory, cardiovascular, and health problems, and those that they cannot be protected by the system. Actually, we know very well that in average all around the world, those that are living in the warmest part of the cities present 6% higher heat-related mortality risk than those that are living, in the coolest part of the cities. But it's not only heat-related mortality and morbidity. During the very last years, we have well understood that during the period of heat waves, during the period of high temperatures, mental problems really are very strong. And we may have, as you can see from the graph, important increase of the hospitalization up to 25% more because really of the high temperatures. You see, for example, the average values for schizophrenia, mood disorders, etc., etc. And this is going to be one of the major problems in the future all around the world. Recent data also shown, for example, that during the period of higher temperatures, the, let's say, increase of the suicide rate is really very high. For example, a very recent study shows that for each degree of temperature above 27 degrees, suicide rate in United States is increasing by 0.7%, and suicide rate in Mexico is increasing by 2.3, 2.4, 2.1%. Yesterday, there was a study published in Australia that shows that in the area of Sydney, let's say, suicide rate increases by about 1.6% per degree of temperature increase. So this is really a very important problem. Apart of the health problems, we know very well that higher temperature affects very much the cognitive performance and the cognitive ability, of our students. And we know very well, according to, let's say, short-term studies, that for each degree of temperature increase above, let's say, 26, 27 degrees, students, they are losing 2% of their cognitive performance because of the higher temperature. And also, studies that have been performed in India as well have shown that higher temperatures have, let's say, an important impact on the cognitive performance of students for the next 4 years. And according to this study, let's say students that they have experienced 1 degree higher temperature during the last 4 years, they have, let's say, 4%, 2% lower cognitive performance, while a 1 degree higher temperature during the last year really decreases the cognitive performance of the students by, let's say, 1%. But it's not just that. During the period really of higher temperatures, the occupational heat stress is increasing. We have much more accidents, etc., etc. We have studies that shows really that those that they work in single work shift under heat stress were 4 times more likely to experience occupational heat strain than individuals working in thermoneutral conditions. And this is very important for India. At the same time, we know very well really the economic impact of overheating. For example, in United States, they are losing $100 billion annually from heat-induced loss in labor productivity. And also a very important decrease of, let's say, the productivity and also of the annual growth. According to some statistics, it is expected by 2100 to have a decrease of, let's say, the global income in the world by 23% because of the loss of productivity in, let's say, our world. And studies that have been performed quite recently, in millions of people have shown that once temperature exceeds 30 degrees, human productivity may decrease up to, let's say, 60%. So imagine what means really that in a country we have a 60% low productivity. It is very characteristic what has happened in Delhi recently during the very big heat wave, where according to the statistic in India, they have, let's say, a reduction of the performance of the outdoor workers by 80%. And this is, of course, this has a tremendous economic impact. Which is really the future of our cities? From all the forecasts and the existing, models, we know that the temperature, let's say in our cities may increase up to 2040, 2050. Not the same magnitude everywhere, but in average, we expect an increase of the nighttime temperature between 3 to 5 degrees and an increase of the daytime temperature between, let's say, 1 to 2 degrees. And this is really very important. And this, unfortunately, affects very much really the low-income population. Statistics, for example, for the Southeast Asia shows that today, the, let's say, a low-income population experience more than 86 days above 35 degrees. While, let's say, if the temperature is increasing by, let's say, 2 degrees, this will increase up to 105, and if the temperature increased by 3 degrees, up to 134, let's say, days, which means that 1/3 of the year, temperature will be, let's say, for the low-income population, higher than 35 degrees. And of course, there is a tremendous difference between the experience and the exposure of low-income population and high-income population. According to the same statistics, actually low-income population experience close to 83 days above 35 degrees, while high-income population, let's say, is under, let's say, lower exposure, 16, let's say, days per year. So apart, of the climatological, let's say, and let's say environmental inequality between low-income and high-income population, there's a tremendous, let's say, impact on the social, let's say, dimension of in our cities. What do we expect for the future? Because of the tremendous, let's say, overpopulation that we experience, we, let's say, we need to have about 440 million new, let's say, homes by 2025, next year. And by 2030, we have to build, let's say, about 77 billion square meters, which is equivalent, to the total, let's say, surface of China. And to understand really the rate of new construction, actually we built one city of Paris per week. And of course, this brings us to the very important problem of the energy consumption in the near future. We know very well that by 2050, the energy consumption for cooling will skyrocket. There are several, let's say, scenarios, but the energy consumption for cooling may increase between, let's say, 1,000 to 2,200%, because really of the overpopulation, because at the same time of the increase of the temperature. It is characteristic that a recent study from LBNL in the United States showed that the energy consumption of a single Indian city, Mumbai, may be about 50% of the total energy consumption of the United States by 2050. But although we expect that the tremendous increase of air conditioning, unfortunately, this has a very important social stratification. A very recent study that really calculates the penetration of air conditioning in 4 countries like Brazil, Mexico, India, and Indonesia as a function of the income shows really that while the high-income population in all these countries, they benefit almost 100% from air conditioning, and also the middle class, the lower class really suffers from, let's say, the high temperatures and the lack of air conditioning. And by 2040, because of the non-penetration of air conditioning in the low-income population, they expect really to have about 100 million households, or 343 million of people in these 4 countries suffering from, let's say, the cooling, let's say, deficit. And of course, I don't really like to mention the tremendous increase of the peak electricity demand because of the cooling. For example, in India, during the last 3 years, the increase of the peak electricity demand is close to 14% per year, 15% per year. It is impossible for a country really to have an increase of 15% per year. This, of course, decreases the hours of electricity availability. These are the bad news. Do we have good news? Yes. During the last 15 years, we have important, let's say, developments trying really to decrease the temperature of our cities. We have developed very efficient heat mitigation technologies, and really we have implemented these mitigation technologies in more than 200, 250 cities all around the world. I don't have the time to go through all the mitigation technologies, but I like just to concentrate on the development of the so-called super cool materials. Super cool materials are materials which present very high reflectance, but at the same time, they emit, let's say, thermal radiation at the wavelengths of the atmospheric window, which means that they can send all the excess heat of the materials directly to the space. So these materials present subambient temperatures up to 10 degrees under the sun during the day. Studies that we have performed actually together with colleagues from, let's say, Calcutta, Ansar Khan, and the others, we have seen that really the use of these materials may, let's say, decrease the peak temperature of cities up to 4 or 5 degrees, but at the same time, when they are, let's say, are used in order to modulate the optical properties during the winter time, may contribute at the same time to increase the winter temperature up to 2 degrees. So these materials may be a win-win solution because may decrease up to 4 or 5 degrees the temperature during the summer and increase the temperature of the winter up to 2 degrees. The problem of these materials is that they present very high reflectance, so can be used only on roofs of the buildings. So to decrease, let's say, the reflectivity of the materials and allow the use of these materials, let's say, in vertical surfaces, in pavements everywhere, we have compensated the decrease of the, let's say, reflectance by using an additional, let's say, cooling mechanism, which has to do with fluorescence. So we have developed, let's say, color radiated coolers, which present much lower reflectance, high, let's say, performance, but at the same time also have color you may have. Testing that has been performed last year here in the desert of Australia have shown that these color materials have exactly the same performance like, let's say, the white or silver super cool materials. So now we can have color super cool materials, let's say at any, at any color of any color that performs at subambient temperature under the sun. which is very important is that these materials, when compared against, let's say, conventional white paints using cool roofs, color materials, for example, orange or yellow or green materials, may present up to 3 or 4 degrees lower surface temperature than the conventional white materials. A big, let's say, implementation, a large implementation of these materials has happened really recently last year in Riyadh, in Saudi Arabia, where we have succeeded really to decrease the temperature of the city up to 4.5 degrees by using cool and supercool materials. And the most important, to decrease the energy consumption of the buildings up to 35%. But the most important is that when these materials are used, for example, on the roof of low-income housing, may decrease the indoor temperature up to 10 degrees in Sydney or, let's say, in other Australian cities, and of course in India. So instead of having people suffering at 40 degrees, we can really decrease indoor temperature with very, very low cost, let's say by 10 or maybe 12 degrees. So it's a win-win situation, which really helps very much to improve the condition, you know, in low-income population. I'd like to conclude by saying that although we have a very important, let's say, development during the very last year, this is not enough. And this is not enough because in overall, let's say, the policy that has to do with the implementation of the technologies in our cities is not something which is really defined and decided by, let's say, the engineers or the technological people. It has to do with, let's say, the overall economic conditions in cities. And the best way, really, or the way that it works actually under our system, is to monetize the cost, really, of the overheating. So if really we try to monetize the cost of the overheating, which means that those that they increase the temperature of cities, they have to pay, and those that they decrease the temperature of cities, they should have, let's say, the benefit. So in this case, we create a new market for indoor overheating, for outdoor overheating, very similar to the market which is created, for example, for the decarbonization or, let's say, the increase of the CO2 in the atmosphere. So this is the economic, let's say, tool that has to be used in order really to implement all these technological developments in our cities. So my conclusion is very clear. We are suffering because of the overheating, and especially because really of the very high increase of the temperature and the, let's say, frequency of heat waves, especially in Southeast Asia and especially in India. Important overheating, we have very serious impacts that affect really the quality of life and also the economy of, let's say, the countries. Fortunately, we have developed very important mitigation technologies that can decrease now the temperature of cities up to 4 or 5 degrees. We expect that in the near future, we will be able really to decrease the temperature of cities up to, let's say, 6 or 7 degrees. It's not enough really to have technological developments. At the same time, we have to develop the proper financial and political tools in order really to promote the use of the new technologies in our cities. Thank you so much.
So I'm Vikram Murthy. This was a wonderful presentation, Professor Matt Santamoris, and I think everybody who listened to you, beginning from me, has been really happy to listen to you. First, about what is going wrong, and secondly, about mitigation. Both of these are most important to look at them very carefully. And I thank you so much for your presentation. It was so nicely put together, and I appreciate it as much, I'm sure, all the audience over here. So, Prashant, you can put on your mic. And I will request Neetu to see if there are any questions and we can answer them. And Prashant, you can also ask any questions to Professor if you like, and so can the others by putting it in chat. So Neetu, you can read out any questions if there are, and Prashant will answer them or I will answer them. Neetu, you can hear us?
Yeah. So Vikram sir, before answering those questions, one question to Prof. Math, like means he's working with a lot of Indian scientists, especially with Prof. Ansar Khan. And for Kolkata, a lot of research has been done by him. So Prof, means in your opinion, what should be the possible mitigation strategies for cities like Kolkata? If that you can summarize means in sort of few key points based on your research findings.
Thank you, Prasad. First of all, before really we try to implement any mitigation technologies, it is very important really to decrease the strength of the heat sources. We start from there. For example, anthropogenic heat and everything which is released, in the city. We start from there. Then, we need really to understand the efficiency of the different mitigation technologies. In several cities, for example, the use of cool or super cool materials may offer important benefits. Calcutta, from the existing calculations, may offer, let's say, super cool and cool materials may offer a very important benefit, may decrease the temperature of the city by 3 or 4, let's say, degrees during the peak, and has important, let's say, energy benefits. Greenery is very important, given that it does not really increase very much humidity, and also that, let's say, we have to consider that additional greenery needs water, and this is an important problem, and also that because of the very important increase of the temperature, in most of let's say, the cities, greenery may not really perform, let's say, properly regarding cooling. And I mean that, trees above a certain threshold temperature do not really evapotranspirate, or has a very small, let's say, evapotranspiration rate, which means that the contribution of, let's say, trees, if are not very well irrigated under high temperatures, may be, let's say, not high, or even, let's say, close to zero. So all this specific, let's say, information has to be collected together. And actually, once really we decrease the strength of the heat sources, and we, let's say, increase the strength of the heat sinks, like cool materials, like greenery, and many other things, we are able now to decrease the temperature of the cities up to 4 or 5 degrees. This is possible for most of the, let's say, Indian cities. And another dimension that I like really to, let's say, underline is that by using all these technologies, we perhaps be able to decrease really the concentration of pollution. Pollution, we know very well that in most of the Indian cities is very high, and this cost perhaps millions of deaths, in the country. So I think that by using, let's say, appropriate holistic, let's say, policies, we may improve the environmental quality of the Indian cities, and especially decrease the temperature during the winter period. At the same time, let's say, decrease the concentration of pollutants. And the most important, in my opinion, really try to decrease the rate of increase of electricity demand in India because of, let's say, the overheating, the electricity demand for cooling. If really India cannot succeed to decrease this 14% of the peak electricity demand per year, there will be an important problem, because 14%, it's impossible for a country, any country in the world, to increase the installed capacity by 14% per year. The cost is tremendous. The cost not only, for the creation or the development or the construction of the new power plants, but so at the same time, the cost of let's say, of the fuels, the pollution which is created, the emissions, and also, the impact on the quality of life of people. So I think that, in my opinion, who am I, of course, to, let's say, express an opinion about India, but if you wish really my, let's say, point of view, I think that it is a very high priority to decrease really the use of air conditioning in India, and your effort to, let's say, promote passive cooling is extremely important. I think that passive cooling, when applied in Indian cities, may decrease the, let's say, the cooling energy demand up to 4 or 50%.
Thank you so much.
50%.
Yeah, it's a very valuable insight, bro. Thank you so much. So, yeah, from audience, Neetu ma'am, do we have any question for Prof. Matt?
Yeah, we have few questions here.
A couple of questions we can take.
Yeah. So there's any case study available and the initial data collection format designed by the fraternity. So they are asking if you can share.
Can you repeat the question? Sorry, I lost.
Prashant, can you just read that question? It's in the chat.
No. You can check it on a Q&A section.
Right. The Q&A, sorry. Yeah.
Where is that Q&A? Ma'am, you can read me, so I'm not able to see from here.
Okay,
Is the one by
Okay.
Jeslu Celine Jacob?
Okay, yeah.
No, it's by Attila Narendra. The first two questions.
Any case study available and the initial data collection formats designed for the fraternity, please share. Please share the material vendors if possible. Yes, please send me an email and I will send you some information.
Okay, thank you. Neetu, any other questions?
Yeah, it's there is.
So there's a question from Celine Jacob. Just read the second sentence onwards.
I will read it. Thank
Okay,
you
please.
for
Yeah.
the very informative presentation. It was indeed an eye-opener. As rightly pointed out, low-income population are the most vulnerable who face energy poverty. Will these passive strategies such as super cool materials be adequate, or should India focus on subsidizing air conditioning?
So I will answer that question.
This is an extremely interesting question.
Yeah, and Matt, you can please add to what I'm saying. Since I'm from India, I'm just expressing my view. Subsidizing anything is never a good solution, because when you subsidize, you will increase usage and you will not bother about the energy consumption. So I'm not in favor of subsidizing. I'm certainly in favor of support of changing inefficient air conditioners to very highly efficient air conditioners. For that, there may be a subsidy or a payback and so on. Certainly the use of cooling materials or super cool materials, that would be really the much better way forward. And Matt, you can add to it, and so can Prasad.
If you allow me, yes, I fully agree with you. Subsidizing air conditioning will be a disaster for India. Why? Because first of all, you will increase the peak electricity demand. India is the country with the highest increase of the peak electricity demand in the world. As I mentioned before, is 14%, close to 14% per year. 14% more power plants per year is out of discussion. So you don't have to subsidize air conditioning. On the contrary, you have to subsidize, in my opinion, really let's say the quality of buildings. Passive cooling, as Prasad has explained before, more insulation, better shading, better ventilation, nighttime ventilation, all these technologies may decrease the cooling demand of cities, let's say the cooling demand of buildings up to 40 or 50%. The other important issue is that, adaptive comfort really is very important. It has to be, let's say, in my opinion, let's say implemented in your country. Why? Because if you follow, for example, the standards of, let's say, the conventional American standards, 25, 26 degrees inside the buildings, this is not proper for India because people is adapted to much higher temperatures. So if you apply these technologies and you really put buildings under 24, 25 degrees, people will learn, will be habituated under these temperatures, and they will lose their adaptive capacity. So I think that with proper, let's say, passive cooling techniques plus ceiling fans, you may really have an important decrease of, let's say, the cooling demand and the peak electricity demand. I'm not saying that you will cover 100%. It's out of discussion. But even 50% will be an extreme, let's say, contribution to the country. If not, the problem, the financial, the economic problem, the energy problem, the pollution problem, and in general, the environmental problem will be really tremendous.
Thank you, Professor. So, yeah, please.
Sir, there is a question from ministry side. So, Lama ma'am, do you have any question?
There's a question about the temperature in let's say in classrooms. This is also very important. There are, let's say, hundreds of experiments performed mainly, in let's say in developed countries, in temperate climates, that shows that once temperature is above, let's say, 25 degrees, we are losing, let's say, 2% per degree of temperature increase. On the contrary, there are studies in India showing that even under 29, 30 degrees, the cognitive performance of students, let's say of air conditioning and natural ventilated buildings was the same, 25 and against 29, 30 degrees. On the other hand, there are studies also in India performed, for millions, I think 4 million of people participating in the national, let's say, competition, showing that when really the exams happen under higher temperature, the performance of the student was much lower. So it is a problem really, and especially this has a cumulative impact on, the cognitive performance of the students for the next 4 years because they are losing, some capacities. There's another study for India showing that by 2050, if really the temperature increase as forecasted, happens there, students, they may lose, let's say, the cognitive capacity of 6 months per year, which is really tremendous. So the impact of, let's say, higher temperature on the cognitive capacity of students is a major problem all around the world. And really, it's a problem that affects very much, low-income population. This is very clear, for example, when we compare the results of the PISA exam. The PISA exam is an exam that happens all around the world, 5,000 at least per country, same exams, etc., etc. The analysis of the PISA exams during the last 15 years has shown that countries that they face really higher temperature, they have a lower performance, not because of, let's say, racial or any other reasons, but because of the higher temperature. According to an official report, people, for example, in Brazil, we can say the same for India, present 6% lower performance than people from South Korea because of the higher temperature in the area. So it is a very important issue that has to be considered.
Very nice. Good answer. Prashant, we are on
Yeah,
topic.
Lama ma'am have some questions. So, ma'am, you can
Yes,
speak.
yes, Professor Matt, thank you so much for your enlightening session. And I'm very glad that you've pointed out two important things. That's the effect on mental health. And also, you spoke about low income population heating. So, this is very, very relevant for a country like India. So, while going through the report prepared by Professor Anand and team and other studies that I went through, I've understood that passive heating, like passive cooling strategies, is a little bit more benefited when there are space around. But whereas if you look at the urban settlement in India, especially where the lower income population lives, the space is very constrained. So I would like, my question for you is, you can get back. I would be writing to you also. So what are the passive strategies that are successful and benefited to this low income housing in slum areas like India or Brazil or any places? Sorry.
Yeah, this is a very important question. We expect by 2050 to have more than, let's say, 2 billion people living in slums. The quality of, let's say, settlements and houses is really bad, much better than me. What we can do, many things may happen there. It's not only a technological problem. We don't really have to consider that it's just a technological problem. It's more a political problem. It's a financial, it's an economic problem. So I think that actually we need really first to, let's say, improve the environmental quality of the areas that these people is living. We have to start from there. Because usually in these areas, temperature is much higher. For example, in the United States, where we have really credible statistics, low-income population is living in areas which present up to 7 degrees really higher temperature, while, let's say, white population or high-income population is living in areas with really an overheating up to 1 degree. So first, we have a very important increase or very important overheating, in these, let's say, areas where low-income population is living. First, we have to fix this overheating. If we don't fix the overheating, the energy demand and the discomfort and health problems and all other type of problems will persist in these areas. We start from the overheating, number one, and we know how to do it. We know how to improve it. Second, we have to improve the quality of the housing. We have really to subsidize and try really to help people to, let's say, improve, the condition of life. If not, the health penalty will be tremendous. I'm sorry to say, but we don't have really credible statistics from India, or we don't have enough statistics for low-income population. All around the world now, we have about 500,000 people dying per year because of the overheating. And this may increase up to 2 million. On the other hand, if we don't really invest for the low-income population, the cost, later will be much higher. Actually, the cost of overheating in the world is close to $450 billion per year, American dollars per year. By 2050, the cost will be 2.3 trillions. So if we are not proactive, the cost will be tremendous later, with a huge, really, health and mortality, let's say, penalty. The other thing is really the loss of productivity. There are studies that shows that by 2050, 2060, perhaps the productivity in India may decrease up to 20 to 25% because of the ability of outdoor workers to perform because of the very high outdoor temperatures. So the loss of productivity will be another important issue. So in my opinion, we start really from the outdoor environment, we improve the quality of the housing. It has a cost, this is sure, but the cost, of non-activity or the cost of inaction will be 10 times higher. And this is extremely important, and this has to be, performed by using technology which is developed, in the country, not technology which is imported, because, countries like India do not have really the luxury to import expensive technology. You have the best, scientific potential. You can develop technologies, and you are developing technologies that really may help the population. If really this investment is not happening in India, the country will pay 10 times higher penalty by 2050.
Thank you, Professor. That was an eye-opening answer. And I think the key takeaway from you is to first address the overheating before trying to mitigate it. And that's most important. That takes several stakeholders to do it. Those who develop, those who live, the government, the local government, volunteers, and cross-subsidy of the municipality to improve all of that. And so I think the city which I live in, Mumbai, is badly in need of addressing all these type of things. And I think a bigger discussion with the Ministry of Environment is needed by our team. And I think Professor Lama will help us to have that discussion, and we will certainly take your help and advice.
Thank you.
Prashant and
Yeah.
Nitu, I think we've come to the end of a very wonderful
Yes.
session. It began with your introducing the book, and Professor Matt Santamoris giving us a wonderful expansion of all that from all over the world, but more importantly, how to address it, and a
Yes.
lot of detail. And I hope the audience has been happy to listen to this. And I thank all of you for attending. And there's a chat which has been put up by Professor Prashant Anand. It gives my email ID. For those of you who haven't got your questions answered, you can email me. I will pass it on to our backend team, and we will respond to you within 2 weeks' time. So thank you all for this wonderful meeting. Nitu, you can conclude, and you can say anything you like before you end the session, please. Thank you very much for helping us, Nitu, and running this program so well.
Thank you, sir. Thank you all the participants who attended our webinar. It was a very engaging and a truly insightful session. And We appreciate our speakers that share their expertise and their ideas and discussion. I think everyone found this discussion informative and inspiring. And if anyone have any further questions, you can email to us. We had put our email ID in the chat box, as well as we will be sending you the book link along with the thank you email. So from there, you all can download our book and have a wonderful day. And thank you again for joining us today. Thank you.
Thank you, Prof. Matt. It's very late night there, around
My
11
pleasure.
p.m. So I know you're sleeping
Thank
very
you.
late.
Thank you, Professor Anand. I hope you're safe. There's a cyclone coming towards your way, I heard.
Yeah, but it's not that much impactful here. Means maybe it moved towards Orissa. So we are
Okay. Okay.
rain is
Just-
happening, but the intensity is not that high.
Okay. 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 Thank you so much, and thank you for making this happen before Diwali. So
Thank you so much, ma'am, because you coordinated. That's why this happened.
Yes, yes, it's wonderful. And we are also happy that this was done.
yes, thank you.
Thank you,
Mr.
everyone.
Thank you,
Thank
Neetu.
Thank you.
You can end the session now.
Yeah.